There will be times when you're asked to find a higher order derivative. So for example, we've been looking at the first derivative. Could you be able to find the second derivative or the third derivative, the fourth derivative, the fifth derivative, so on and so on? We indicate that we're trying to find a derivative other than the first derivative by adding more parentheses. When you are finding higher order derivatives, all the same rules apply. So I have two examples here, one where we'll find the third derivative and one where we'll find the second derivative. So let's take a look at these. On the first one, if I'm trying to find the third derivative, first thing I'm going to do is I'm going to find the first derivative. And when I go to find the first derivative, I realize that's a very easy process since I just have a polynomial here. So I can go ahead using my power rule and get the first derivative is 15x to the fourth minus 8x plus 3. Well, I'm trying to get the third derivative. I've got the first one. Now that I have the first one, I'm going to take the second derivative. When I find the second derivative, all that means is I'm taking the derivative of the first derivative. Using the same rules, I can use the power rule. I still have a polynomial. I get 60x cubed minus 8. My 3 drops off because it's a constant. Now that I have my second derivative, if I take the derivative of the second derivative, I will get my third derivative. And again, it's a polynomial, so using my power rule, 3 times 60 is 180, x squared. Again, my constant goes away, and there's my third derivative. Looking at the second example where I find my second derivative. Well, in order to find the second derivative, I have to first find the first derivative. Well, I notice that I have a product here. I have x times sine x, so I'm going to go ahead and use the product rule. I'm going to say that f of x is x. And f prime of x is 1, g of x is sine x, and g prime of x is cosine x. Therefore, my first derivative is the derivative of the first times the second, so sine x plus the derivative of the second times the first. I'm always going to put my x first so it's not confusing about whether that x is multiplying or part of my cosine function. So x cosine x. I'm now ready to take my second derivative. So I notice this first term is easy enough to take the second derivative of. I can just use my formula that says the derivative of sine is cosine. However, my second term, I'm going to have to use the product rule again. So I'm going to set that up and take all my derivatives at once. So f of x will be x again. F prime of x will once again be 1. G of x is now cosine x. Therefore, g prime of x is a negative sine x. And so then my second derivative is the derivative of sine x, my first term, which is cosine of x, plus, now taking the derivative of my second term, the derivative of the first times the second, so negative cosine x. Oh, I'm sorry, it's not a negative. I'm misreading my own writing. So cosine x. Then it's quotient rule, or excuse me, it's a product rule, so add, so plus the derivative of the first times the second. So since it's a minus sine x, I'm going to go ahead and right away say that plus is going to become minus sine x. And now I can combine some like terms, so my second derivative will be 2 cosine x minus x sine x. Notice I could continue and take the third derivative, the fourth derivative, the fifth derivative, so on and so on. Each time I take a higher order derivative, I'm just taking derivative of the derivative before it.